we're streaming now. Cool. Hello, everybody. Welcome to this meetup, DevOps Malmö, with Christian Clausen and 5 lines of code. So this is closer. If you're on the live stream, if you just type the questions, then we have people here that can repeat the questions to Christian or whoever should answer it. And all of you here, you can just raise your hands if you have any questions. So we're going to do a 45-minute talk. And after that, there's going to be a break with pizza. And today it's Capiche doing the sponsoring of that pizza.
And the word of the sponsor. Hello, everybody. Nice to see such a great crowd here today. Anybody here heard about Capiche? Yeah, cool. We are in the building next to here, so just 100 meters away, and we are a software company, of course. We have been sponsoring Foo Café now for a couple of years because we like this kind of live forum for easy drop-in and lots of different subjects. What we at Capiche do is that we make it easy to explore clinical data, any scientific data actually, but we're very strong in the life science. Normally we don't have an agenda when we say that we sponsor the pizza, but today we actually have an agenda because we're looking for a really good developer, a full-stack developer with emphasis on front-end, but a good knowledge and understanding in back-end as well. So if that sounds interesting, please just grab me in the break. Over to the night star, Christian.
I'll just need to turn everything on, I think. Okay, hello. Yeah, thanks for coming. It's awesome to see so many of you. My name is Christian, and I'm going to talk a little bit about refactoring. My official title is like Technical Agile Coach. The important part there being the technical part, but people tend to confuse it with other Agile coaches. I come from a very strong background in technical excellence as a developer, then tech lead, and then now I work more with culture, talking to companies about how to do transformations and how to do DevOps better. I don't know how fast I should speak. I think it varies with how nervous I am, and I'm fairly nervous right now. So let me know if I'm going too quickly. Also, then it'll be way shorter, and we will have to wait for the pizza. And also, if I'm speaking, if I'm mumbling, or if I'm not articulating enough, also let me know. Cool, yeah, I'm going to talk about refactoring, and that's because I wrote a book about it. It's here. You can come look at it afterwards if you want to, or you can, of course, buy a couple copies each. That'd be nice. I want to tell you about one of my first experiences as a tech lead, because that's sort of what spawned this whole journey for me into how to do refactoring differently than other people do it. And it started as, I've been a consultant since I was done with university, so it started, as many of my stories do, with a new project. And this was the jackpot project, you know, the best kind of project. It was a technology I had nothing to do with before. I didn't know it at all. It was a huge code base that nobody had any sort of idea what was doing all of it. It was constantly breaking, as large code bases tend to do. We had one person who knew how to deploy this software, so legendary bus factor there. We had a bunch of tests, actually. The problem was all of them were red. And the architecture was a jumbled mess, right? Everything was all over the place. It was very noticeable that we were the third consultancy company to get this code base. And each time a new consultancy gets it, you're being like, well, we'll do the architecture differently and better. So, and none of us got to finish, of course, so it was very weird. Horrible mess of a code base to work with. And whenever we had to change something or fix something, everybody would be like, let's just see if we can not touch this thing. You know, we were really scared of messing with it. Also, when I came to the project, I had, of course, no special powers or anything. I was just another developer like the other developers were. And I saw immediately that they had all of these problems. And I had an idea. I thought, how can I make this project the project that every consultant wants to be on? Because if I can do that, then I'll have fixed all of these problems, right? Or at least people will be sort of working really hard to make it better, and I'll get the people's best work. if everybody wanted to be there. So that was sort of my idea, and I pitched it to the team and to the manager and to the product, to the what's it called, the customer, and I pitched it to all of the important people, and they agreed to sort of let me try at least, have a go at this, see if I could actually run this team better or make some changes that would last. So the first, at least it couldn't get any worse anyway, so really it was low risk action to take. But the important part is just I didn't have any official new title, or management wasn't behind me or anything. I just talked to my team, and we agreed that we were going to try to do things differently. So the first thing I decided to do was get rid of all of the dead weight. All of the things that could slow us down, we didn't have time for that because we needed to start moving, and we needed to start doing something about all of the problems. So the first thing I did was remove basically all of the comments in the code and also all of the red tests. If they're red, they don't give us any confidence at all. So, and there was no way of fixing 700 tests. So I was like, let's just delete them and not spend any time on them, and then we'll start from basically scratch. I also said to the customer that they couldn't contact my developers anymore. They had to go through me, because every time they contacted the developers, they would have the context switch, and they will have to do all these different things. And when one of my developers had demoed something for the customer, they would always be like, oh, that's cool, can we also get? And then they would request something completely different, all outside of the process and stuff. I'm hoping some of this sounds a little bit familiar to some of you at least. So I said, no more doing that, everything has to go through me, so at least then I would know how bad the problem was and how much waste we had in this process, and hopefully stop this domino effect of being behind all of the time. I also took the action of removing the person who knew how to deploy. He had a tendency to make himself the bus factor. He wanted to be the only person that could do something, and that was too dangerous for the team. So I started out pair programming with him until I knew how to do all of the things he was the only one who could do, and then I asked him not to come be on the project anymore, and I taught them to the whole team. We also later, of course, automated all of these parts. Oh yeah, talking about pair programming, I just one of the things that has that I talk about most often in my job as a technical agile coach is how to do pair programming right. And so it's a very short tutorial, so I'll just give it to all of you guys for free. It comes from this guy, Llewellyn Falco. And he says, from head into code, an idea must go through someone else's hands. So it just means that the person at the keyboard isn't the person doing the thinking. And that's great for learning new things. And it's very important, and it will become important also in this story. The second step I took was we needed to increase our test coverage, or at least I thought so. Being just newly appointed and young and green and inexperienced, I thought this will be easy. I'll just tell them, from now on, all the new code has to be tested, right? And then, of course, nothing happened. Nothing changed at all, because you can't just tell people that now they're going to work differently. It also turns out, of course, that to do testing, you need the code to be well factored, and to do the refactoring, you need the code to be well tested first. So we sort of had a chicken and the egg situation here. We couldn't really get started on anything. And so I went back to my, in Danish we call it a thinking booth. I don't know what it's called in English, but I went back and had a think how to do this. I figured, okay, if refactoring is a problem, then maybe that's where we should start, by refactoring the code. And so I introduced a semi-weekly tech talk where I would introduce a new code smell, and then we would sort of work on that for 2 weeks and try to see if we could get the code to slowly move forward. And so, of course, having introduced all these TED Talks and all of these code smells, you know what happened? Nothing, still, for some reason. Very weird. It turns out that to do the refactoring, people wanted to understand the code they were refactoring, and that's very difficult, especially when it's poorly factored, and it takes a lot of time to understand it, and it takes time to refactor it, and it especially takes time when the code has a tendency to break a lot, which our code base did all the time. So we were again gridlocked completely. We couldn't move anything. So then I heard about a guy called Woody Sewell, who had this wonderful saying. He said it's about creating an environment where excellence is inevitable. And I thought, that's what we're missing. It's the environment. It's all of the other things that people, even though I've removed all of the, most of the waste from the developers, we still had like a lot of stress to deliver features and to do all of these things. And I figured, okay, I have to create some time in their calendar to actually sit down and do this stuff. And so I introduced a concept we now call Improvement Mondays, where every Monday they would just have all day to do whatever they thought was most important. So I basically just gave them a full day to do whatever they thought was cool. This is the other thing apart from pair programming that we see a lot of positive effect of when we introduce it into teams, because the first thing they do is fix all of the problems that annoyed them last week, and then at some point they start focusing more on learning new things, experimenting with new tools, and they can get a lot of benefit from that. So I gave them Improvement Monday, and we'd already have the TED Talks, and we still had all the other things. So, of course, nothing happened still, because you can't just, even if you have the time, even if you know what you got to do, you also need to get it into your hands. You need to, understanding what a code smell is not something you can just do in 30 minutes on a Friday, where we had the tech talks. So we were sort of stuck in another gridlock where I couldn't get people to actually do some of these things. So once again, I went back and had a really long thought about what we could do. Really long think about what we could do. And so I came up with this idea. What about not using code smells? What about using rules instead that they could just easily take and apply? And so I went to a lot of books and resources on how to do, what was good code and clean code and all of these things. And I sort of tried to figure out what are the important criteria for these rules that I'm trying to create for these new things. And the first criteria is it should be easy to remember them, because they're already filling their head with all of this model of the code base and what it's trying to do and all of these things. So it was very important that I didn't put in more stuff into their heads. They were already overloaded quite a bit. They should be syntactic also. I mean, you should be able to look at the code and discern immediately, without thinking, whether the code was complying with the rule or not. This is important because cognitive capacity turns out to be the thing. I didn't know about that back then, but I do know about it now. It's the thing that's actually constraining a team like this, and most software teams are constrained on their cognitive capacity. And again, if you try to put more stuff into their head and require them to think, they're not going to change. I feel myself talking really fast. Am I talking fast? Okay.
We like your excitement.
I'm really excited. I mean.
So can you say anything about the technical environment that this happened in?
Are you meaning the tooling or the code base?
Yeah, or whatever technical environment.
So it was we worked on a
Like
Microsoft-based system. So it was I think the core was SharePoint, but there was basically no SharePoint left because we had sort of built this shell around it a bunch of times that was so thick that it was really SharePoint was just our database, which was weird because it's a wonderful system. And I didn't know SharePoint at all, and it was written, of course, in C#, all of it, and in a bunch of different ways, and with old versions of TLS and all of the good things you get from a legacy code base. Yeah, cool. Yeah, so the rules needed to be easy to remember. They needed to be syntactic. So two things that go out of the head of the developer that de-stresses them. And the third thing was they should be safe to follow even when you don't understand the code, because the code base was completely incoherent. So I had to come up with something that I trusted you could do without screwing things up more than they were at least. So they should be safe to do. I also had to come up with new ways to do refactorings, because we, again, didn't have any testing, and all of the resources on refactoring out there come from the extreme programming world at some point. Which is very heavy on testing, and it requires a lot of testing and coverage. And then you can do, when you have a bunch of tests, you can do a lot of cool things, like move really, really fast and just break everything, and your tests say no, and you just reset your branch, and then you just start over, no problem. But when you don't have tests, you can't be as reckless as you can with tests. I like to say tests are like brakes for cars. They enable you to go really fast because you can stop really quickly. We couldn't do that, so I had to come up with new refactoring patterns. And I was going to think, what can I do that is safe and that I trust my developers to do, even on a bad day, that won't screw up our code base, or where there'll be a very low risk that they'll introduce more bugs. And the first thing I came up with is the thing that most developers do anyway, copying and pasting. It's very unlikely that if you copy something from here and paste it straight, that it's going to have errors in it. So, and we already have a lot of practice with it. So I figured that's a pretty safe thing we can do. I also, because I come from a background of type theory and semantics and a lot of programming language theory, I figured why not use the compiler? In the languages we were on, we had actually a compiler, in this case C# and TypeScript, that can actually do a lot of things and can catch a lot of errors. At least if I design the patterns so that they take advantage of the fact that we have a compiler instead of the testing. So whenever we get an error, it's fairly easy to find them because the compiler tells us exactly where, and it is also usually easy to fix because there are not many fixes if you have types on your things that will work. The final thing, and the thing that I also try to apply most in my own life, is taking small steps. Like, if you do something small, you break something small. You can't break the whole thing. Usually, it's at least less likely. So smaller steps on everything, smaller batches at every process. So if I just ask developers to take really small steps, then hopefully they won't mess anything up in those small steps. What I've learned since is that when you ask people to take the same small steps 30 times in a day, they'll get bored and they'll skip them. But that's not the fault of the refactoring patterns. That's the impatience of the developers. And after having introduced these new rules and refactorings, stuff started to change, actually. I started to see an effect on the code base. The code started to be easier to maintain and the bugs went down. Of course, we had one final hurrah of a huge bug that took weeks to fix, but then after that, we were pretty much, we saw this nice curve of the fragility of the code base going down, which was super cool. And I'll get back to why it went down after we look at some code, because it's been a while and I haven't looked at any code. Also, I've been driving for 4 hours, so I need it. So let's look at what these some examples of these smells and refactorings. I'll need these. Okay, cool. One of the first smells people learn is don't have long methods. And it's a great smell, it's a great advice also, don't have too long methods, but obviously the first question people ask is, what's a long method? What's too long? When should I actually apply this? Is it 30? Is it 700? I mean, and so when I was sitting down with all of these books and having to interpret what actually was a safe way of doing this, especially this one was important to me because I felt like this was the one that could motivate all of the other refactoring, so it had to be fairly small. I settled on 5 lines, which you might have guessed already from the title of the talk and the book and my life, basically. So I said it's 5 lines, and I've learned since that someone did a study on what's the lowest bugs per line ratio, and it's around 5 to 6 lines of code, which was great. I also, of course, had to go and define everything else, because if I want to make them syntactic, people can't have any questions once I've talked about them. So for me, a line of code is something that isn't just a brace and isn't a blank line, right? So if it has a for or an if you put that one up there, it still counts as 2 because I also count the semicolons, something like that. But it's what you think intuitively that it is. So there shouldn't be any surprises. I did that for a bunch of different refactoring smells. So I also made them into cards afterwards. So there's a bunch of them here. Also, these are also the refactoring patterns. But now I figured we could just take a look at a small piece of code and talk about how to take it through the process and following the rules and the refactoring patterns that I defined. I've taken the most interesting case, which is what if you have an if-else chain that's longer than 5 lines? If you have something that's not chained like this, you can easily just extract 2 methods usually, and then you're quickly decreasing your number of lines. And I also have advice for when to do that, and blank lines and all sorts of advice for that. But in this case, we can't just, you're not supposed to just cheat and say, well, I can just push this one inside and then extract that first, and then it's the else, and then we're sort of done. That's not what you're supposed to do, because that sort of destroys the structure that the code already has. And that's also one of the things that I rely very heavily on. This code is already running in production. Not this code. I mean, the code we were working with is running in production, and there's nothing that tests that hardens the code like production does. It's also why I dislike the rewrite everything culture that's sort of emerging slowly. It sort of forgets that all of the corner cases and all of the care people have taken to just tune it just right, and we reintroduce all of the off by ones that we've had throughout time. So we are supposed to preserve the structure. That's one of the principles that I did also when I talked to my developers about how to refactor this code. In this case, the way to do this is to recognize that this is actually a type code, and we would like to take advantage. Type codes are sort of a remnant from the C days and from the procedural programming where, this was an int really, it just had names, and then you could just compute things on integers, and it was super nice. Really, we were, in this case, it's TypeScript, I think. We're in an object-oriented language, like a lot of the industry is currently. So we would like to take advantage of the fact that we have an object-oriented language. I'm trying to avoid being in front of the camera, but I guess the camera can't even see me because it's, so let me know if you guys can't see the screen. We'd like to eliminate this type code here, the lights type code. And as I said, we don't have any test or anything, so a type code might be used throughout the code base in a bunch of different places. And so the first step, as I said, is taking advantage of the fact that we have a compiler and actually renaming it over here. So it'll be yellow if I'm adding something, just so it's easy to see. If we add something to the name of this thing and then run the compiler, it'll tell us all of the places that we're using this enum, because it's all error. It's now using an unused thing. I should note that all of my things here don't work if you misuse your compiler, like using reflection or doing automappers and all of this fancy new stuff that can really mess up, the compiler, which was the whole point of using a compiled language, I guess. But in this case here, it highlights all of the places which we need to look. There could be bunch more, but we'll focus, of course, on this code, because it's easy. Oh, I should maybe also explain. In Denmark, we have 2 states of yellow. I don't know if it's the same in Sweden, but it means yellow-red means you're about to get a green light, and just yellow means slow down. And so the regular traffic light, or at least in Denmark. I'm from Denmark, by the way. Guess I hadn't said that. Okay. So we found all of the places in which there's an error. So the next step is to actually introduce a new interface for this thing that we want, that was a type code that will now be a bunch of classes instead. And it's very tedious to do because there's a lot of dumb typing. The thing is, the first thing you do is have the interface with the same name as the enum to have, and then one is something method for each of the values that the enum had. And then, to make it really fun, you also have to have one class implementing the light for each of the values of the enum. So you get sort of 16 new methods in your code. This sort of explodes it out a lot, but it'll get clean again. Just stay patient. It also means we can replace these equals with the is the same thing that we were testing on before. And now we have classes, which is great. Of course, only one of these return true because it's that class only represents one of the interfaces. And where we introduced where we were using these, we also need to put a new yellow or a new red or whichever value we were using. Good. So now we have classes. Classes are awesome because we can actually put functionality into them, and we can make them actually work for themselves, whereas enums cannot. So that means we can take this code here, and we can actually push it into this class by copying and pasting, right? That's one of the things I said was safe. So by copying and pasting this, the compiler will tell you it can't have function, so don't worry about that. It's easy to remove. It'll also tell you that car is undefined, in which case we just introduce car as a parameter. It'll also tell you that light is now undefined, so we change it. I'm pointing in both places. So we change it to this, and all of that was done with the compiler and copy and paste, right? There is no thinking going on here. It's just mechanical doing this thing. We need to paste it into all of the classes, completely the same method. So we haven't done anything significant at this point. We've just moved some code around. And down here, of course, we need to now ask the light to update the car, like this. Any questions to this? All right, just look scared, and I'll see if you have any questions. Cool. So once we have that, we can actually see that in, for instance, the yellow class, it's asking this is green and this is yellow-red. These are constant methods. They always return the same thing. So you can just take this value that they're returning and then inline it into these ifs. Again, it's a trivial transformation to do. And the next thing that we do very quickly is when you have an if false and an else if false, of course, we just delete those parts, and then we're left with just car.stop, which is below our 5-line limit, which is great. And the if completely disappears. In fact, it disappears from all of the 4 classes that we just introduced. So there was an if, there is no if anymore, which is, to me, the first time I saw that, I was just amazed, completely mind blown. Ifs are completely unnecessary, as it turns out. In a well-designed language, you can just do everything with the object system. It's much stronger than the if is. Or alternatively, if you like functional programming, it's literally the same thing. It's just with higher order functions instead of the if. Cool. So we did that for all of the methods, and now at this point, all of these are unused, right? Because we've just inlined all of their values in all of the ifs, and so we can just remove those as well, which shortens the code significantly, I should say. Now we're back to something that looks more manageable like it was in the start. And always when I talk about this, and when people have looked at the book, they come back and they say, what do I do if I have an enum with 30 values? And I'm like, well, you need to do an interface with 30 methods and then 30 classes with 30 methods to implement that. And they're like, but that's super tedious. And I'm like, yes, but you can think about anything else while we do this. And once you're done transforming and pushing all of the code into the classes, all of the is methods will go away, or like 90%. In a few rare cases, you actually do need them because they have semantic meaning, but it's unlikely. Usually they just disappear very quickly. But again, this is where it gets very tedious and where people tend to make mistakes, is because they want to go really fast, which I understand. Then you just need something to break you. That isn't the compiler, probably. Let's say that after some time, after having done this, it turns out we actually needed some other methods. We need to know if the red light is on, yellow light, and green light, because maybe this is like a controlling system for the traffic light or something like that. And we need to know which of them to turn on. So in this case, not only one of them can be true, sometimes two of them can be true. Specifically, the yellow-red one could have two of them being true. But we might look at this code and think it's weird to have two yellow light classes in a traffic light, and we might want to combine them again. It's a pattern I follow a lot. It's one of the flows of refactoring that I've discovered through doing such a systematic approach to refactoring. Is you tend to duplicate, then do some weird transformation in the code, and then unify it again or contract it. It's very similar to the database pattern of the same name. Yeah. And so in this case, we might want to unify them. It's mostly to demonstrate something else that we could do. So we look at where they actually differ. They only differ in this one and in the stop and put into gear. So we can determine that in this case, this can serve as our basis method. It's enough to ask this method to know which of these two scenarios we are in. And so we call it a basis to determine which of them we are in. So if we take this basis and then we just wrap the body of the update car, the other differing method, in the question of which one are we in. In the one case, we're in the one where it's true, and in the other case, we're in the one where it's false. And so we haven't changed the code at all. We've just done the opposite operation that we did earlier, where we inlined them. And there is some math going into you can always use n-1 basis booleans to unify two different things. You could also do it for a different constant. If it's a string or an integer, you obviously only need one, and a bunch of other things. The thing to see here is just it's very easy to do this. We haven't changed any of the code yet, and so now the cool thing happens. We take the body from this one and paste it into the body of this one, and the body of this one paste it into the body of this one. So I think of it sort of like multiplying fractions, dividing fractions, I guess, where you flip them and then you put them together, something like that. And that's also what we're doing here. I've also put in the else because they're using the same value. So they obviously, because they're basis, they can never have two paths being true at the same time. It wouldn't make any sense. And so now, if we look at the two things, we have the update car method is now completely equal in both of them. The only difference is the constant method that we chose for our basis. Am I going too fast over the code? That might also be the case. Okay, cool. So when we have just a constant method differing in value, the next thing we do is, also because we have two things and it's definitely one of these two, because that's how Booleans work, I also just simplify that a little bit, but that's a minor point. It's just to make it a little bit prettier to look at. Now we only have this one differing in the two. So what we do is we introduce a new parameter to the constructor of this, and that might look a little bit weird if you're not used to TypeScript. But here we have a private, this will become a field variable or a property or whatever you want to call it, where we give it whether it has the red one on or off, and then we just inline that into the places where we used it, like before. And so now we can determine it from the constructor, and now these are completely equal. The yellow and yellow-red are completely the same. And when I was learning this stuff and coming up with these things, I actually did it to both of them to actually make sure in like an editor and look at them to see that they were in fact completely textually equal, because I wanted to be extremely safe while doing this stuff. And they are, at this point, they are always completely identical, so you can just delete one of them. I think that's the next thing. Yes. So we just delete one of them, which is super nice. So now we've unified two of the classes. And in fact, we're in a different scenario, like we were at the beginning. Here we're not violating the 5 lines rule that every method has to be less than 5 lines, because it is. But we are violating a different rule that says you can't have if with else. So in that case, that also applied to the Euler situation. But again, we're in a situation where this is actually a type code. Booleans are type codes too, like integers and like enums, and technically also strings, I guess, but mostly in C#. So we have the same. We can go through the same steps again of making this, making an interface for this thing. It's a little harder to rename Boolean. Also, that's not quite what you want, because this is in a specific context. But you can still make an interface for it, make classes for it, and then push the code into that, and the whole thing continues sort of in this sort of flow. Like I mentioned, the other flow, which was duplicate, then transform, then unify. In the same way, one of the other fundamental flows that we go through again and again is this flow that has the function of eliminating an if, or an if-else chain, really. And so the first thing we do usually is extract the method. What I showed here was already nice and compact. It didn't have anything extra around it. So we extract it, then we introduce all of the classes and interface, and then we push the code into the classes, making the if disappear. And then we usually inline. The original method that we started with had only one line left, and when a method has only one line, or a function, we might as well just inline it. If we're not breaking the scoping, the whole reason it got extracted was usually because it was too long, and now it's one method call for one line. Seems fair to inline it. Oh, good, that was code. I got my heart rate under control again. Cool. Let's talk a little bit about why this actually helped on the code base, and why the bugs went down, because this seems like we're adding a lot of indirection, and we're adding a lot of classes and a lot of lines. The code actually becomes much larger. Luckily, we're paid by the line of code. No, I'm joking. We weren't paid by that. Yeah, but we wanted to be a high-quality team, at least. We also wanted to be a high-quality consultancy where I worked. And so the first thing we need to talk about is invariants, because usually, so an invariant is something that the developer knows that the code or the compiler doesn't know about. So it's all of the things that I keep in my head while I'm coding. A classic example is that array length can never be negative, and it's a fairly safe invariant. But there are way worse invariants out there where people are like, oh, I'm sure this file always exists, or I'm sure I can always contact the database. Something like that is also an invariant if it's not explicitly checked by the code. And so it's all of the things that we keep in our heads while we code. They're also usually where mistakes tend to happen, or bugs have to happen in practice, because it's something the developer knew couldn't happen. Another thing that contributes a lot is coupling, where anytime we share something between two things, a lot of people talk a little bit differently about coupling. I think they talk about it in terms of dependencies or whatever. I talk about it in terms of code that multiple teams share, in sort of the same way that if multiple people own something, nobody really owns it. For me, it's what happens in between teams, and shared code bases, shared functions, shared everything. If your teams are working not as a team but as individuals, I would characterize each individual as a team. If they're not working together anyway, then they're their own team, at least in this definition. And so when we have things where we couple things like this, we tend to have the situation where one team wants to make a change to the shared part, but they either can't because the other team won't allow it, or they're scared to do something bad for the other team, or they're not scared and they do something to the code and something bad happens to the other team. So it's sort of these two situations where you're again sort of locked, and that leads to what I call fragility of a code base, in which changing something in one place has a tendency to affect something seemingly unrelated. And it happens when we have coupling and typically invariants, because it's the invariant being broken that tends to do all of the adverse effects in code. Yeah, and they're commonly they are associated with something like assignments, side effects, exceptions, stuff like that. That's where a lot of the invariants tend to happen. If we look at just a small piece of code to see an example of coupling and of invariants, we can look at this first thing. Usually I would ask you, but you have to have a microphone to answer, so I won't do that. But the question I ask people here is, what can you tell me about all of the code that you can't see here, or all of the things that you can't see? You can tell stuff from just looking at these two lines of code. For instance, I'm sure without even thinking, all of you know what the declaration of this one is, because they can basically only, or at least what the type is, because there's basically only one thing it can be. But even more subtle and sort of fun is that you can also tell which programming language this is from, because there is the uppercase L over here, so it can basically only be C#, which it is in this case. Contrast that to another way to do the exact same thing here, where we have a much lower coupling. I can't see what the data type of AS is. It can be anything, which means I can't have any invariants on it at this point. It's much more free-flowing, and it can move independently. So that sort of shows the difference between raising the coupling and thing. It also means that if we look back at the code that we did, where we eliminated a type code, in this case I've just written enum, but it's just a type code. When we use a type code in our code base, whether it's an enum or a number that we pass around or some value from a database of some sort, we tend to have switches or if else chains. They're the same thing for this purpose, because they check this enum for what it is and then they do something different to it. But we do that in different places in the code, which means we now have to maintain whatever invariants were over here are important to that they're held in the other places as well. So if I think, oh, we have this type of loan in a bank that only elderly people can have, then if that changes one day and it's no longer only elderly people, I might have tied my code to handle that in a special way. And so that's why I went to war against enums, so to speak, and also ifs analysis. It's because they tend to spread out all of these invariants across the code base, making them very difficult to track down, especially if the enum has data associated with it. So if it's something like it can be a shape, it can be a square or a circle, then it would have a different way to represent its spatial dimensions, like a circle would have radius and squares would have length and width and height, I guess. So they have data associated with them, which means this data is where the invariants usually happen. And when we spread this out, again, we're also distributing the data that's associated with these objects. To contract that, when you do it in the code that we ended up with, where everything was objects instead of where we push all of the code into the objects close to the data, we can actually lock that data down into the objects and don't expose it through getters, never pass it as an argument to anything, and completely encapsulate it. Also, of course, I mean encapsulating it in the actual way, not in the way where you have getters and setters at all, which breaks all of encapsulation. In this case, all of my invariants are within this file with this object. I only have to check that within this file I'm consistent at least. It also means that when I have to introduce a new value, if I do that with an enum and there is a default anywhere in the system, I'm gonna miss that 100% of the time. I'm missing that change. But in the case where it's objects with an interface, if I add a new object, I'm asked to actually implement the interface and actually handle all of the places in the code where this is actually used. So it way eliminates a lot of these invariants, or at least it encapsulates them and localizes them, as I say. They have a lot smaller scope, which means it's much less likely that I'll forget them and break them between methods, because I can see them in the same place. I have no idea how fast I was speaking, but that's what I wanted to share with you guys. We've talked about basically sort of these cards, I think, and all of these are in the book, so there's a lot more if you're interested, and I'm also open to questions. I think now we'll do questions from the online, if there are any.
So for the online people that are right now watching live, so you have 5 minutes to ask your questions, and since I get like opportunity because live stream is a little bit with a delay, I can promote something like if you think your company is cool and you want to present something, just Google DevOps Malmö and get in touch with us, so we organize like meetups. And if you think your company is double cool company, so you can present something and plus sponsor Foo Café. So let's take this opportunity to also thank Foo Café for giving us this opportunity to host in this tight moment in the world. So big thanks to Foo Café. And as a double cool company for Capish for sponsoring us today. So we are monitoring. We are monitoring live stream now, and after 5 minutes, live stream will be cut it off. So you get now maybe 3 minutes. So type fast. But meanwhile, if someone has a question, so feel free. We have some minutes for questions.
I haven't been controversial enough.
Yeah, for inheriting legacy code bases with poor or no tests. This is purely out of curiosity, but have you heard of like acceptance testing or played around with that at all? And what do you think about it?
It's a great way to cheat with coverage and get a lot of coverage very quickly. But it tends to be a very hollow way to. Maybe I should say what approval testing is first. So it's where you have some tool. Just you tell it which function to run and with which parameters, and then it looks at the output of that, and then it saves it to a file. First time it does it completely uncritically, but then the second time you run this test again, it'll check, is this output that I'm getting from this function the same as is in the file? And if it is the same, then you know you haven't changed anything. If it's not the same, it's saying, oh, you have a snapshot that's different now. It's also sometimes referred to as snapshot testing. I think it's more popular with front-end things than back-end, but it works for both things. But it tends to be a very hollow way of doing testing because it's not actually you're not actually locking in any of the behavior. What I want from my tests is they lock in the behavior of the code so that I can change the code and restructure it and do a lot of different things to it without changing what the behavior actually is. The problem is, in my experience, when I've used approval testing, is that a lot of people, when you make updates that are intentionally changing the external interface of something, like changing the graphical user interface, people will see, oh, there is a bunch of changes to the snapshots, I'll just update all of them, and they won't actually notice that that's the only time you can use approval testing to actually check that you have only changed the snapshots, which are important. So in my experience, people tend to skip the state of reflection. That's the whole value of doing that sort of testing. In the same way that I say also these rules are maybe they're mechanized, automatable. Maybe they're automatable, but that's not the point, because you still have to put in the human intuition and you have to put in the actual brain of thinking, should I actually unify yellow and yellow-red? Does that actually make sense in the way that I understand the domain that we're working with? And approval testing has the exact, if it makes people think, then it's great. But I tend to my experience is that it doesn't actually make people think, which sort of takes away the whole purpose of it. It's also what I think the greatest strength of doing test-driven development is. It slows you down so that you think before you start typing your code, which is the whole intention. Again, the biggest strength is activating the brain. But it's very hard to get started with these types of tests.
Well, I have a question. There are tools like linters and more advanced stuff that can, it says at least, it detects code smell.
Mm-hmm.
What's your take on them?
So linters, I have a bit of a special relationship with, I guess, because coming from a type theory background, I like type systems, I like compilers, and I can make them check very complex properties about my code. You can teach the type system a lot about your code, especially when you're using something like TypeScript that has both union and intersection types, which is way more advanced than what you find in Java or C# or some of the other languages. So I typically, I've never gotten a warning or an error from a linter that my type system didn't catch way earlier in the process, also way faster usually. So I tend to not use linters because I have a stronger tool at my disposal. I have the same opinion of sort of prettifiers or code formatting. I think it's cool to do that automatically just because then you remove something that the developer has to think about, so it reduces the cognitive load a little bit, but I don't think it actually raises the quality of the code. In general, there are tools that definitely do signal places where you have actual wrong things. I saw what's it called? SonarQube has this cognitive complexity score that they can give you, and it's based on actual cognitive theory, which is nice because that means it probably has some merit in itself, but it's too unrestrictive for me. I want to be more. I want to pull harder in the opposite direction, having smaller functions, having 0 ifs, not just 1 if per function and stuff like that. But there are definitely awesome tools that might be interesting in that, but they're all categorized as static analyzers, I think, for me. Yeah.
Yeah, I'm interested in. So you introduced it to your team, I guess. So then I'm interested. How did they respond to it? Was it some people who were excited, and some people doing it, and some people? Yeah. What's the feeling from the people using this in the end?
Now, after I've also done the book, I get a lot of feedback from a lot more people of using it than did on the project where they had the prototype of these rules. They were not quite as refined. They weren't quite as... right now, they're also designed to build on top of each other way more than I could do back then. It was more shooting it when I saw it kind of thing. But the fact that we had been trying to introduce something and trying to do things differently for already a month or so before anything started to happen, I think just the fact of making progress and seeing something change really gave a lot of morale. I've also learned since that from studies done with actual humans at work, what tends to be the biggest decider of happiness in your work is if you feel progress every day when you go there. And so when we started to actually move something and we could see, oh, we're getting fewer and fewer error rates, that really gave a boost to the mood of the team. Of course, then the big catastrophic failure of 2 weeks sort of took us down a notch, but then we went back afterwards and did more improvements.
Yeah, but so they were willing to do this. Like you had this 30 enum. Maybe that was an extreme example. But is it a pain threshold where they?
Because when I said to them that I have this vision, I want to make the greatest team. I said I gotta have your you gotta have my back and I'll have your back. I'll do everything I can. I'll talk to all the managers. I'll do all the bullshit and the bureaucracy. But then you gotta also. I got to be able to make you do stuff, right? I have to have that thing. So they had sort of committed.
Yeah, interesting.
Well, I have to admit that your talk scared the shit out of me. All the things I have to change now. So I'm going to ask a rather unimportant question. Can you explain the illustration?
I can, yeah. I think it's a. See, now it's embarrassing. I don't remember the actual nationality, but it's somewhere really cold. I think it's close to Siberia or something. I thought when I chose it, I got like 30 different things to choose from, and I could ask for more if I wanted it. But I'd already said that one of the things I really like is for it to be friendly and inviting, and I would also really like having I'd like having a kid, and I seem to be very bad at it in reality. But at least now I have one on my book. I also think for me it was important to have a woman on the front cover of an advanced programming book in 2021 when it came out. I think that sent a great message also because it's something I really think we should care about, and I care about it, and I do everything I can to try to make a more inviting environment for all types of people. And I think this book with the "Let me show you something" it's the exact message I was going for. Yeah, unless you're asking about the names, they're mine and Uncle Bub's.
So having 5 lines of code in maximum 5 lines of code in every function seems very foreign to the code bases I've been working with. So it's mind-boggling. But then I wonder, is there circumstances where this wouldn't apply to, like where the complexity in the code base would rise if we would adhere to these rules?
Okay, yeah, so your question took a different turn at the end. I'll ask what I thought you asked first, and then I'll answer your actual question.
Please do.
First of all, the 5 lines only applies to so really it's not 5 lines. Really it's the number of lines that it takes to go through one pass of your fundamental data structure. So if you're working in 2D like the book is, then 5 lines is 2 for loops, and if something, and a return at the end. So that's perfectly in line with a 2D array-based or table-based system in general. If you're working with 3D, I would say 6 lines of code because you need an extra for loop, and something like that. You could also be working with 27 dimensions, but I don't know how that looks. But so that's really what the actual rule says when you. So they're a lot more detailed when you look into them. But for a first pass, when you're just learning them, just learning the title should be enough again to not mess you up when you go along. And I also say that the second stage, once you've internalized all of the titles of the rules, you go back and you look at all the descriptions and see what their intention actually is, and then slowly you work your way towards having the same understanding of the code smells that I have now, which is a lot more nuanced, and I can sort of see, oh, this is not a time to apply this thing because there's something else in this sort of structure. So certainly it's possible that that it might make the code base more complex, especially because one of my favorite quotes is from John Carmack, where he said, when you introduce abstraction, you actually trade off perceived complexity for actual complexity, because you're making the code base harder to follow. It's a little less of an issue when you have an F12 and can just jump to wherever a definition of something is. But I also like to think that, so once we've taken a very long method and we've split it out into a bunch of small methods, the next step is to actually bundle those into classes with each other. And then once you have a bunch of classes, because you had a bunch of methods, you will now bundle them into sort of packages or namespaces and only expose what's needed. And because we're so strict with encapsulation, we tend to actually eliminate, you don't tend to go 2 levels down, sort of as a classical symptom of being in a layered architecture is that you cheat the layers and go around them. We don't tend to see that at all, actually, which means that you actually can abstract away details without significant loss of functionality or freedom to do what you want. So I don't think it's not much of a problem, at least in the code bases that I've worked with. We haven't seen that the actual complexity went up significantly. There is obviously a price for fewer bugs. It's a lot easier to, if you can break things fast, you can make things fast. Sort of the.
Any more questions to Christian?
I like the idea of the refactor Monday. What do you call
Improvement Monday.
Improvement Monday. Did it stick around? Like,
yeah, and I still use it in my job as a technical agile coach. The first thing I ask a team to do is to reserve the Monday to not do anything. And it seems scary, especially for managers. They get really scared initially.
Yeah. In my experience, they tend to eventually start to fade away somewhere. But
in the places where I've been, we have I also have rules for it, where it's like we do the first thing where we pitch things and recruit for different projects that people want to work on. We also have a rule that says people can't be alone for a project; they have to work together, because one of the big benefits is that we get better to working as a team, and we start practicing some of the stuff that we would like to use in our real work but can't because we're not proficient enough to not be stressed by it. So something like mob programming and pair programming would be some of the things we practice on the Improvement Mondays. The teams that get enough practice in those things to start using them as active tools in their regular work tend to have a lot more retention than the other teams, because they have something concrete they can show from Improvement Mondays to say to the managers, no, look, we are actually using these things for the rest of our work also. Or say, oh, we solved this thing that cost us a lot of manual work. In a few months, it will pay off again. I have seen longevity with it. Of course, it can go away, especially when people get more busy. And I haven't met developers that weren't busy yet. But you just got to have someone be the advocate and be the very, they have to own the day themselves, especially when I, as a consultant, usually go away after a few months.
You caught my attention with Improvements Monday. Is it specifically designed to be Monday, or is it any random day, or have you give them freedom to choose it within the week, or how do you find the best?
Yeah, so usually when I go out and introduce it now, I don't have any power again over the teams. I'm just a consultant, so I just come in and I ruin everything for everyone, and then I go away before we can see any effect of anything. There's a reason it's Monday, and it's because it's if you do it in one of the middle days of the week, people are already there. Again, it's about cognitive capacity, and they're already in a product mode, and the momentum of that will tend to carry over to that day, and it's very hard for them to create space to do something new, to do the experiments, to learn something, because they're still thinking about the thing that they couldn't quite fix yesterday. I've always been trying to teach developers that whenever their software works and all the tests pass, or they just closed something, take a walk, just 10 minutes to enjoy the fact that right now you're not busy, you've just closed something, because we're so bad at doing that as a field. We tend to just, okay, let me pick up the next thing, and then you have just 10 seconds of not being frustrated, and all of the rest of the time you're frustrated. So if you do it in the middle day, they're still in that momentum because they didn't fix it. So if you do it on the Fridays tend to sort of be swallowed by meetings and other things, and people are in a different place mentally than they are on the other days. So the reason we choose it as Monday is, for one, that you don't have the cognitive inertia from all of the product days that come before it, but it also means that during the weekend, people are excited to get back. They're like, oh, Monday will be cool because I can do this thing, I can fix that problem that I had, or I can sit down and read a book, that's gonna be super cool, or something like that. So Monday seems to have the very best effect. I've seen every team thinks the same thing as they do with their ticketing system when I say it should be a physical thing because the dopamine gets released when they do this thing and it doesn't get released when they do this thing. But they don't do it in an online system, right? They skip it and then their Scrum Master calls them and says, where should I put this ticket? But it works when you do it physically. But everyone I've told that to says the same thing. Oh, it's just much easier to do it online anyway. And I'm like, yes, but you destroy the whole point. So when I say to people it should be Monday, they also go back and say, oh, we tried to do it on Thursday. As it turns out, it doesn't work. I'm like, okay, no surprise.
All right, let's not take it any further. Oh, you got a question? Okay. Yeah, okay. That's your last 1 minute, and then we just cut off the live stream and we go for pizza, because pizza is there and no one likes to wait. So you get one last minute. Okay, let's do it.
I'll try to speak quickly. Anyway, so you mentioned pair programming and that you coach that. I'm curious on what your thoughts are on ensemble programming.
Yeah, also love it. There are two tools designed for the same thing, but at different scales. The thing is, again, they're based on cognitive theory, where when we work on a problem, when developers code something, they fill up their entire head with that thing that they're doing, which makes sense because we work in a problem-solving domain, and it's a complex domain. We don't know what the code is doing due to Turing completeness. We don't know what the user wants due to users, and we don't know what something is going to be worth because the market is also unpredictable. So we have three fundamental unpredictable things that we have to combine and juggle in our heads while we're building something. So it's basically impossible. It's actually amazing that we can do it at all. So when I want people to learn something new, to actually take up new skills and change their habits, the only thing that persists when they're working in this complex domain is the habits that they already have. And so you can't build new habits without also expending some cognitive capacity, and you can't do that if you're solving a problem. Pair programming and ensemble programming solve that problem by having another person be the brain so that you don't have to. So the person at the keyboard doing the typing can actually learn new things and help say, oh, I think one of the things we can introduce is having people commit more often to version control. And so they can be like, oh, I think it's been a little while since we committed to version control. Would this be a good time to do it? And the fact of being reminded at that at regular intervals and having two people help each other learn something new works really well. So as a tool for learning and developing the team and growing both the teamwork, the spirit, it's a great tool. It also works to sort of demystify a lot of what goes into the imposter syndrome that I think almost everyone in our field has, where they think, oh, I'm the best. We have this amazing constellation of being both super arrogant and having a lot of imposter syndrome, where people, and I meet it everywhere I go. There is someone who's like, I'm the best programmer in the world. I just don't want to do pair programming because what if the other people see that I'm not as good as I think I am? And I'm like, how can those two coexist in one person's head? But they do, and they're everywhere. And ensemble programming has the effect of sort of demystifying that and starting to, once you've seen how everybody actually behaves in a code base sort of through ensemble programming, you can start to learn where your place is in that sort of role, and you can start to build much better relations to people and actually use it way more effectively. But again, it comes with an initial cost where you're bad at doing it and everything's chaos and you get, frustrations and arguments and everything seems bad at the beginning. But if you stuck with it, you'll start to increase your psychological safety, which we of course know from both State of DevOps and the rework Google Project Aristotle, where they actually show that that's the biggest predictor of performance in a team is the psychological safety. So feeling safe, sharing your ideas and making suggestions, and you get that a lot from ensemble programming.